Welcome to Spring 2016 orientation for the Data Science program for online and certificate students. Congratulations, welcome. We are excited. Program directors and I are excited to have you. My name is Kayla Sroggins. If I have not already talked to you via email or phone call or face-to-face, I am the records manager at the Data Science program, so I handle the admissions, kind of registration, streamlining, all that administrative stuff for you guys. Basically student services. So if you have any questions, feel free to email the Data Science account, and I try to get to that within 24 hours. So I know there's a lot of you, as you can see, and then there's a couple other cohorts of you as well. But I'm really excited for you to be here to meet you all in person, and I'm really glad for the online students who will also be seeing this. I'm going to turn this over so we can get started, because you're wanting to get to the nitty-gritty of everything. I'm going to turn it over to our program directors, Dr. David Weil and He Ding.
So I'm David Wild. I've been a professor here in the School of Informatics and Computing for just over 10 years. Obviously originally didn't come from here, if you can detect an accent. I was originally from the UK. And I actually worked in industry in Michigan for a good number of years before coming here. The data science program we formed just a couple of years ago was its genesis, and it's probably it's definitely the most exciting thing I've been involved with since I got here, so really great to be part of this. So I'm the director of the academic programs in data science. Professor Ying Ding is also here. Ying is associate director of the programs and directs the online program, so she takes a primary responsibility for the online program, and I take a primary responsibility for the residential program. So right now, if you're a residential student, I'm going to be a primary advisor. We may bring in some more faculty advisors over time, but for right now, I'll be a primary advisor. For the online students who are watching on video, Ying is going to be a primary advisor. We are going to back each other up, so if one of us is out for a while, then the other one can help you out. So I'm just going to give you a little bit of context about the program, and particularly in the context of the School of Informatics and Computing and what we're doing in the school as a whole. Then we'll kind of just get into some more tactical details about the program and advising and taking courses and so on. I want to talk a little bit at the end about some of the skills that and how to go about building your data science skills during your time here. So I think we kind of oriented you to the people. Kayla is kind of, or the data science office that Kayla runs is really your first point of contact for most things. Primarily because I'm not an expert at all in administrative stuff and how to get things done at the university and how to release locks on courses and all this kind of stuff. I really don't have a clue, I'm afraid. I wish I did. Kayla is going to be a main point of contact. We're going to have the staff working with Kayla, so it may not be Kayla, maybe one of the staff gets back to you. My main interface with you will be as advisor, so more on the academic side and the content of what you're learning. And the same for Ying. There's a link there to the data science faculty, so we have a subset of the school's faculty and some faculty from outside the school who are the ones who are primarily responsible for the program and teaching classes. And most importantly, there's you. You're our second major cohort of residential students. The first was in the fall of 2015. As of now, we should have about 337 students in total, 189 online, 123 residential. So there's quite a lot of you, but we're really working hard to make sure you all kind of can have personal contact with us and have a really personalized experience going through this course. So the School of Informatics and Computing was actually formed in 2000, and it was formed based on the observation that it was no longer sufficient to be doing computer science as a kind of theoretical or kind of ivory tower discipline. The observation was that computing was becoming pervasive, so computing was going everywhere. So we had to be kind of doing field work in computer science as well as kind of theory in computer science and kind of building infrastructure. So the idea of informatics was that we do the theoretical stuff, but we'd also research how to apply it. So we started working in domains like bioinformatics, health informatics, human-computer interaction, complex systems, even music informatics, and had actually brought in domain people to be doing computing in those areas. We have a highly successful undergraduate program in informatics that derive from that, and also PhD and master's programs in other areas of informatics and computing. Since 2000 we've grown. We merged with the computer science department and the information library science department, and now we kind of cover the whole breadth from early kind of theoretical computer science right the way through to very domain applications. The 3 units in the school, a unit is kind of like an organizational unit, so where the faculty have their homes is really what the unit is. And the 3 units are computer science, informatics, and information and library science, okay, ILS. The way you'll see it is in the course code. So some courses are CSEI, that means they're computer science, taught by computer science faculty. Some info, which means they're taught by informatics faculty. Some are ILS, taught by ILS faculty, and also stats is the other unit we have, which isn't in our school right now. You'll see some more units coming in over time, but that's going to affect the flavor of the courses, right? So CSEI course is going to be more kind of computer sciencey, an informatics course may be more applied. So for example, we have an applied machine learning course, which is housed in informatics, and then we have a machine learning course in computer science, which is just a little bit more theoretical, right? So you get some different flavors from that. Data science is what we call a virtual program. So there isn't a data science unit. The data science draws on the faculty and the courses from these other units, right? We are building, pure data science courses in the middle of it, but all of them are housed in one of those units right now. So all of them will have either ILS, CSEI, info, stat, course number. Okay. So it's a little confusing about these units, and we've got programs and so on. It takes a little bit of getting used to. The school's rapidly expanding. We have actually I think about 100 faculty right now. Big undergraduate program in informatics altogether. About I think we're up to, these are slightly out of date, these figures. We have 3,000 or 4,000 students. We're really pushing to increase female enrollment both at the undergraduate and graduate level. Computer science on average tends to be 15 to 20% female versus male. We've kind of pushed it into the 20s. We want to push it further, and we've got lots of activities going on within the school to help promote more female enrollment. Across the school, we have excellent job prospects. We'll be hearing from career services later on. Have a fantastic career services unit, and there we have really, really high employment rates across the school, and high employer satisfaction as well. A lot of research going on in the school, and it's our hope that you'll be able to interact with faculty on research and learn more about their research. Some of that will come through the courses, or it may come through other mechanisms. We have a significant number of major centres in the school, in most of which are in areas highly related to data science, cybersecurity, bioinformatics, complex networks and systems, data and search informatics, extreme scale technologies, security informatics, network science, data to insight, digital science, and so on. We also have lots of other research areas going on. This is a list that I won't go through, but just to make the point, there's lots of world-class research going on in the school. So the data science program started as a certificate program, launched in January 14th. We launched the MS in November 2014, initially for online students who came in the spring of 2015. And our first major residential cohort was last fall. you remember I said about this school was based on this idea that, you know, we should have a broad view of computing. Computing was becoming pervasive, and therefore we need to do field work in computing as well as theory, right? Well, we've applied this to our data science program too. That flavor of the school comes into the data science program. So the way it comes out in data science is, well, data's everywhere now. You know, a decade and a half further along, it's the same, except rather than computing, we say data. So data's everywhere. It's like electricity. It's all over the place, but we don't know what to do with it yet. So we take a view that is a very wide range of activities really important for handling data. In fact, my kind of working definition of data science right now is a bunch of computational and statistical techniques that are suddenly very important for the future of the world, right? So it's not just about some statistics on a computer or using Hadoop. There's a whole breadth of what this means and kind of the change that's going on through data science. So the way that impacts our program is we allow people to take both technical and decision-maker paths through the program. I'll say a little bit more about that. But it's not just all about being technically proficient, it's about being able to know what to do with that technology. So there's a human side to it, an analysis side to it, and we really want people to be able to take their own paths through that, so there's a lot of flexibility to do that. We think it's important to train the next generation of data science leaders, so thought leaders in data science, not just practitioners who actually do the stuff. A word about the courses that we offer in data science, right? We made a basic decision, and I'll get to some more on this in something I say later, but the basic decision was we're not going to focus on teaching you nuts and bolts kind of basic skill set things, right? The reason is we've got world experts in areas of data science. You know, we've got world experts in visualization, in high performance computing, in network systems, data analytics, and so on, right? We don't want those people to be spending their time teaching you C++. We want those people to be spending their time offloading that specialized knowledge in their brain so you can get the value from it, right? So what we say is that our aim is that the courses will be primarily added value of a basic skill set. So, for example, Professor Jeffrey Fox teaches a course on big data applications, right, which is all about being able to take your skill set and bring it together to solve problems, right, real-world scientific problems, right. We leave it to you to build a skill set, right. And I can help you and Yin can help you as advisor, but there's so many really good ways to, you know, you want to learn MongoDB, okay? Well, we could teach you a course in MongoDB, but you can go to Coursera and get a course in MongoDB. You can get a book on it from Barnes & Noble. You can sit down with somebody else and self-learn. There's so many really great ways to learn MongoDB. Just do it. Do it. and then you'll be able to use MongoDB along with your classes here to have really kind of enriched skill sets. Okay, so that's just a basic thing that we've decided. We're trying to make sure it's embedded in world-class research. So there's lots of amazing research. We've got everything from, you know, people predicting the stock market by analyzing Twitter feeds to developing the next Hadoop, right? So a ton of stuff going on here, and we want to kind of keep what we're doing embedded in the research as well. We have a pretty comprehensive set of residential courses. We're working to build that and particularly build capacity on that. We also have a rapidly expanding set of online courses. Residential students can take the online courses too. We have separate sections for the online courses for residential students, but those courses are open to you as well. We have some really fantastic online offerings available. And then there's the website, datascience.soicindiana.edu. This is just a little snapshot, actually slightly out of date, of some of the research going on. We get lots of grants. We've got people actually researching education, and you know, running MOOCs and all this kind of thing. So a huge amount of going on. Okay, so that was kind of context. I want to just kind of narrow down a little bit now and just talk about a few things which are probably confusing for you, not because of you, because they are kind of confusing, right? So the first is paths and tracks, right? We're working to rationalize this, and we may change terminology we use, but for right now we have two terms, paths and tracks, right? Path really doesn't mean anything formal. What path means is a guide to help you through your degree, right? The observation is that, if we had to cluster data scientists, right, the first clustering would probably be into, firstly, people with a more technical skill set, as in computer science, technical building infrastructure, and people with a more data analysis application skill set, right, maybe in particular domains, right? So that would be a first clustering. So we call that decision maker, one cluster decision maker and one cluster technical, right? So, and we're trying to tag courses as either decision maker or technical. There's a lot of fuzziness in the middle, some are in the middle. But we just want to help you. If you want to take broadly technical training or more broadly decision maker training, we can help you do that. That's all path means. What we're really trying to do is help you decide where you want to get to 2 years from now, what kind of job you want to get, and then get you oriented the right way to do that, right? That's really the aim here. A track is something more formal, and we're very much in the embryonic stage of right now. So the idea of a track is it's a specialization, so it's a narrowing of training for something in particular. Ultimately, we'd like to be able to offer, for instance, health track or medical track. We're talking to medical school and so on about being able to have specializations in different domains. Right now, by default, everybody is what we call general track, and that's the right place for you to be, right? And we do have one track called computational analytic, which is a constraint in the courses you can take. And that to the more computer science technical side, right? I wouldn't advise you to opt for that right now. There's no reason you have to, and it constrains the courses that you can take, right? You can take a very technical path through the degree without having to declare a computational analytic track, right? So I'd advise you all right now just to stay on general track. It's fine. You can have if you want a highly technical training, you can do that, right? We can help you with that. So advising, say a little bit about what Ying and I are doing as advisors. The purpose is to guide you through the program as a whole, help you make good decisions about what classes to take, and help figure out what your career path is going to be and how we can steer you on that, and to address any academic issues that arise. Okay, that's all we're good for. We're not good for kind of. I don't have access to any systems that let me do magic with the international services and unlock things, and I don't have any. I can't. There's certain things as faculty we have power to do, but there's a whole lot that you think we have power to do that we don't. Right? The administrative stuff really we can't do a lot about. Sometimes if something's gone wrong, we can call somebody up and complain, and try and make something happen. Right? But really, a lot of those things like. Just about the mechanism of doing a degree, we can't help too much with. What we can help with is the academic side, the content, your careers, where you want to go with your careers and that kind of thing. Also, for all administrative matters, start with the datasci@indiana.edu or the Data Science Physical Office, which right now is on 611 North Park. They can at least steer you in the right direction. On the other side, if you've got questions about a specific class, you're better off going directly to the instructor for that class. Email them, keep emailing a few times because some are more responsive than others, right? So if you want to know whether you can take their class because you know Java but not C++, then it's best to contact the instructor directly and get it from the horse's mouth, as they say, rather than from me indirectly or from Ying indirectly. Okay, that's what we're not here for. What we are here for is everything in between. So to get advising help, the first point of call is this document, which I think you should have all got right, which is an advising document. Did that go out yet, Kayla, or is it coming?
It did.
Okay, so it's like a PDF document which lists all the courses, right? So that's the first port of call as a reference point. For quick advising questions, send an email to dsadvice@indiana.edu. That'll go to myself and Ying, and one of us will respond back to you. Again, we try and do it within 24 hours. Um, we're both open for individual appointments, half-hour appointments when you need them. Use them sparingly because there are 300 of you, and we've got a million other things to be doing as well. But this is really high priority. Us helping you through the program is very, very important to us, right? So if you need to sit down and talk with us, we're both available. We have slightly different ways of doing appointments. For Ying, you've got open office hours, right? So you can drop in. I'm hiding more behind my "you can book me" thing, but Ying's okay with you just dropping in during office hours, right? So there's a Monday and Friday 9 till 3:30, either by online, by Skype or physically. The final kind of bit I wanted to cover is just some of the top questions that come up when we're advising. One is, often one of the first things people say to me is, what courses should I take? And I say, hang on, just back off a minute, right? So the real question is, where do you want to be 2 years from now, right? Or whenever you finish the degree, right? What skill set do you want to have? What do you want to be able to put on your resume? What kind of job do you want to do? Do you want to go into a research job? Do you want to go into a infrastructure job? Do you want to go into a data analysis? Where would you really, in your ideal world, want to get to 2 years from now? Then the second question is, well, what can we do to make that happen? And then the third question is, well, what courses are going to help you do that, right? So that the courses you take should derive from where you want to get to. Don't be just rushing to choose the courses that you think look best on your transcript or something. Really, nobody cares about your transcript, right? People care about what skills you've got. The two things employees care about: your skills and your experience applying those skills, right? And then maybe, having the piece of paper of master's degree, of course, is important, right? But what's on your transcript is going to be way down there somewhere, right? So think about where you want to be in 2 years in terms of skill sets and experience, right? So what's the skill sets? Well, this little diagram here is my kind of way of thinking about this in my brain. It's not necessarily absolute, but this is how I think about it. And I think of the data science skills of a data scientist in these 5 different bags, right? Now, not everybody's going to be an expert in all these areas, but you'll probably be an expert at 1 or 2 of these areas, but we want you to have some breadth across these areas too. And then the little guy at the top is the data scientist kind of mixing together the skills to solve real problems, okay? So the first ones, and these move on the left side, it's more technical stuff, and on the right side it's more human application stuff, right? So there's a kind of progression here. So systems is all about the infrastructure, physical and close to physical infrastructure that you need to handle big data, right? So these things like cloud computing, Hadoop, Spark, high performance computing, right? It's the stuff that makes it all possible for big data. So this is obviously highly technical, and it requires a highly technical skill set to pull it all together, right? The second is big data management. So this is the infrastructure for the data, right? And the first approximation is SQL, Oracle databases, right? It's databases. But increasingly we have NoSQL, MongoDB coming along as extremely important, have semantic databases, graph databases. So there's a whole area of and then there's the question of how do you manage all that data in different data lakes and all this kind of stuff, right? So there's a whole area of big data management. There's programming, which in this context is like glue. So in data science, programming is the glue that brings these infrastructure and data management stuff together to actually do stuff on the other side, be it apps or be it middleware infrastructure or whatever, okay? So the most common language is Java for that. Python is probably for more kind of a little bit more scripting is important too. C++, then languages like Scala, which are kind of related to Java, are increasingly important, right? Now, you don't have to be a programmer to be a data scientist. That's one thing we want to say, right? But you should have at least some feel for programming, right? But if you're going to learn a language, I would kind of say Java, right? So there's a programming skill set. Then there's a kind of line. So everything systems, big data management, programming is about infrastructure, right? Pulling all this stuff together to do stuff. It's not helping anybody. You're not solving any real world problems with that. You're just making it possible to solve real world problems, okay? So then you have analytics. And this is about what some people think this is data science, but we'd argue this is just part of data science. Things like statistics, visualization, machine learning, data mining, being able to take that data and that infrastructure and come up with stuff which might change the world in some way, right? Or at least solve somebody's problem, are obviously there. The final is what I call human data interaction, which are really human level things, but extremely important, right? If you don't get the human data interaction right, you may as well not bother with the other stuff, because this is where you get to the nub of actually making a difference in the world. So this includes kind of big level things like policy, strategy, ethics, security, but also how do we take all this stuff and apply it in particular domains? So how do we apply this in a hospital, in a biomedical domain? How do we apply it in finance and so on, right? So there's a whole skill sets needed in those areas, which are not primarily technical skill sets, require an understanding of the technical side, but they're about problem solving and looking and see what's possible and what the dangers are and all kinds of stuff, right? Okay, so our hope in this degree is that you'll develop some skills across this. You'll get a breadth of experience across these areas, but you'll probably decide to kind of focus in on one or two of these, right? So you might become an analytics person and primarily you're doing data mining, machine learning and so on, or you might become a systems person and be developing Hadoop systems or whatever, okay? The second question is what about jobs? The first thing I would say is that the school has a fantastic record with employment post graduation. It's too early to get good data for data science because we're too young, but the school as a whole, 99% of masters and PhD students, you can see this report down here on the right, it's available on the website, secured employment or continuing education within 6 months of graduation. Okay, there's some information on starting salaries and stuff. Have a huge range of employers who are very closely associated with the school, Amazon, Target, Accenture, big companies, and fantastic career services. So I'd really encourage you to use career services. You'll be hearing more about them later. We have a career fair, 2 career fairs each year. The next one is coming up very soon at the Convention Centre in Bloomington. Strongly encourage you to go to that. You're going to meet tons of employers. Don't be afraid to go if you feel you're not ready yet because you haven't built your skill set. Just go along anyway. So just talk to people, take your CV along, see where you get. You at least learn a lot of information, right? There's a report came out on technology salaries, just came out a couple of weeks ago. Data science average salaries 103 to 138, gone up to 109 to 153 this year, 8.9% increase. So it's really, I'm not going to promise you're going to make 153,000 on your first job, but it's very much in demand, huge demand for data scientists, and it's increasing. So all the signs are good. We've got good career services, we've got good history in the school, and there's rapidly escalating opportunities there, right? It's more about finding your right place in it. In terms of internships, there are internship opportunities. I work with employers and career services will be feeding by email lists internship opportunities, or you can go off and find them yourself or go to the career fair and find out what they are. Okay. We don't have a formal internship program in the degree, but we strongly encourage you to go for summer internships and so on to get experience. I mean, having that, like I say, this the skills plus experience. The internship gives you experience.
So welcome and think about like what David said about these skills. How you want to build these skills? Because the job market, they need different people. They need people to create infrastructure. Like Stark become very popular in many different application infrastructure building now. And also there's a lot of people really need analytic skills, how you can, like Walmart, how you, based on the online data to predict how many people will show up, online next Monday. I mean, so there's lots of different requirements. So really think carefully when you start. Now you have enough time to think about where I want to go, how I'm unique in which part. So take the one you feel strongest and you feel comfortable and you want to go for that. Okay, not just follow, oh, this is very trendy, I should do that, but I'm not good at infrastructure. I hate cloud computing. I like some others, but you have to force yourself to go there. Don't do that. To follow your heart, follow your uniqueness, and build a strong part of you, okay? So we are ready here for you guys, and feel free to drop by my office and share with any thoughts of you, any help, we're willing to help. Yeah, for the online program, I think, this might not be interesting for you guys, might interesting for people, online student. So we actually will spend a significant time to further enrich our online program. We will bring more courses available for fall semester. So we are working very hard on that now.